Lesson 31, Conditions for Parallelograms. The objective for your lesson is to prove that a given quadrilateral is a parallelogram. Up until this lesson, we've looked at all the properties of parallelograms, and we said, well, if a quadrilateral is a parallelogram, then it has these properties. In this lesson, we are looking at all the converses. If a quadrilateral has these properties, then it is a parallelogram. So, we have 5 theorems that are conditions for being a parallelogram. If one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. You'll note that it has to be the same pair of sides that is both parallel and congruent. 632 states, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. And 633, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. And the other two, if an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. So you see here that angle A is supplementary to both B and D. 635 says, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So in this one we have a picture of a figure, a polygon, ABCD, and AZ is congruent to ZC, BZ is congruent to ZD. Just by looking at this picture, then, we should remember that since these are bisected, this is a parallelogram. So example 1a, we want to show that JKLM is a parallelogram for the values A equals 3 and B equals 9. Step 1, we'll find JK and LM, the two side measures, and make sure they're the same. So given JK is 15A minus 11, we substitute and simplify and we get 34. LM is 10A plus 4, that's given. We substitute and simplify and we get 34 also. Then we want to compare KL and JM. So if we look at these, we use what's given and then we're going to substitute and simplify. KL is 5B plus 6. Substituting in, we get 51. JM is 8B minus 21. And if we substitute and simplify, we get 51. Since JK and LM and KL and JM are equal, then JKLM is a parallelogram by Theorem 632. Also, another example, this is one where we have expressions for the angles. Show that PQRS is a parallelogram for x equals 10 and y equals 6.5. So, first of all, we use what we're given. The measure of angle Q is 6y plus 7 degrees. Substitute 6.5 for y and simplify. We get 46 degrees. So, the measure of angle S is 8y minus 6. That's also given. Substituting 6.5 for y and simplifying, we get 46 degrees. The measure of angle R is 15x minus 16 degrees. That's given. If we substitute 10 for x and simplify, we get 134 degrees. Since 46 plus 134 is 180, R is supplementary to both Q and S, and PQRS is a parallelogram by Theorem 634. We have another one, example 2a. We're going to apply the conditions. Determine if the quadrilateral must be a parallelogram and justify your answer. So we're given a parallelogram, or something that looks like one, with 107, 73, and 107 degrees in the corners. This must be a parallelogram because 73 degrees is supplementary to both of its corresponding angles, or consecutive angles, rather. And by Theorem 634, the quadrilateral is a parallelogram. Let's look at this one and see if we can decide if it's a parallelogram. We have opposite angles that are congruent, but it's only one pair. Since it's not both of the pairs, it doesn't meet the conditions, so we can't determine if it is a parallelogram or not. To say that a quadrilateral is a parallelogram, by definition, you must show that both pairs of opposite sides are parallel, or that both opposite angles are congruent. Let's look at an example in the coordinate plane. We are given some endpoints, vertices of a parallelogram, and we want to show that this is a parallelogram by using the definition. So find the slopes of both pairs of opposite sides. The slope of JK is negative 5/3, and the slope of LM is also negative 5/3. The slope of JM is 3/4, and the slope of KL is 3/4. Since both pairs of opposite sides are parallel, then JKLM is a parallelogram by definition. Example 3b. Again, we want to show this by using Theorem 631. Find the slopes and lengths of one pair of opposite sides. Because this is where we said if one pair of opposite sides are both parallel and congruent, then it is a parallelogram. So let's look at AB. The slope of AB is negative 1/4. The slope of CD is negative 1/4. So they are parallel because they have the same slope. And then we would use the distance formula to find out how the length of each one. AB is the square root of 17, and CD is also the square root of 17. Since they have the same slope, they are parallel, and since AB is equal to CD, then they are congruent. So by Theorem 631, ABCD is a parallelogram. So you've learned several ways to determine if a quadrilateral is a parallelogram. So you can look through the theorems, and you should remember them in both directions, and see which one you should apply to make the proof the easiest. Your conditions are both pairs of opposite sides are parallel. That would be by definition. One pair of opposite sides are parallel and congruent. That's 631. Both pairs of opposite sides are congruent. That would be 632. Both pairs of opposite angles are congruent. That's Theorem 633. One angle is supplementary to both of its consecutive angles. That's 634. Or the diagonals bisect each other, and that would be 635. So depending on the picture that you're given, or the problem, how it's written, you would know which condition you're using to prove a parallelogram. To show that a quadrilateral is a parallelogram, you only have to show that it satisfies one of the sets of conditions. Let's look at an application problem. The legs of a keyboard tray are connected by a bolt at their midpoints, which allows the tray to be raised or lowered. Why is PQRS always a parallelogram? Well, if we look, this is a midpoint, which means that these two segments bisect each other. So by theorem 635, PQRS is always a parallelogram. Now you try. Show that each quadrilateral is a parallelogram for the given values. Remember, we're plugging them in and comparing the sides and making sure that they add up, or the angles to see that they work. And then you're going to explain which theorem you used. And then determine whether each quadrilateral must be a parallelogram and why. Or if you have enough information, you can justify your answer. And then show that the quadrilateral with the given vertices is a parallelogram by using the given definition or theorem.